Hi, in this video we'll look at how to take a form that is super challenging to handle. Number one, it has handwritten text, and number two, it has radio buttons that are checked, and then this also has check boxes that are checked sometimes. So we'll have to not only get the right information, we'll also have to render it in a way that large language models can understand. And to make matters worse, in the second page we have a driver's license, which is in fact in the wrong orientation, rather than landscape. It is in the portrait orientation, but we should have no trouble. We also show how we use the LLM Whisperer playground to quickly extract and see how things are. You can see how format preservation occurs, and then you can also see how, for example, it's able to pull out the information from the driver's license even though the license itself is in the wrong orientation, right? What we'll do is that we'll write the code. I'll show you how to generate JSON data, which is something like this from this document. So basically we'll have all the personal details pulled out. We'll also have information from the license pulled out. On to the video. Last time we looked at how to use LLM Whisperer to process checkboxes and radio buttons in PDF forms, which are fairly common. So here's in front of you is the repository for that particular project that we did in the last video. So basically we take a form which has checkboxes and radio buttons, but then, for example, we might need to find out that this is indeed a US citizen, and we might also need to find out whether, where check boxes are involved. For example, check if you are the business owner. So if this person is a business owner, then we might need to process the checkbox, and in the case of the citizenship, we may need to process the US citizen bit, right? And we used LLM Whisperer to pull out the data. So it's super important that you have a text extraction service which is able to both identify form elements like checkboxes and radio buttons, but also render them in a manner that large language models can actually interpret. For example, this is the rendered output from LLM Whisperer. So if you look at this, it's rendered the radio button like this, so that the large language model can actually understand that this is the option that's checked, right? And if you look at the output here, you can see that it's very beautifully layout preserved, which is super important for large language models to make sense of a form which is dense with this kind of information. Similarly with marital status and things like that, and also check if you're the business owner, right? So this is also super important. And we created a final JSON, which is like this. So we got the citizenship information, which is part of a radio button, but then we also got other things like, is this person a business owner, which is true, right? Because it's a checkbox and it was checked, right? We took this output that LLM Whisperer gave and passed it on to a large language model in, I think, pretty much under 100 lines of code. This is 99 lines of code to be exact. So this is actually pretty simple code. We are using LangChain to do the prompt management, prompt template management, and we are using Pydantic to essentially create the models for the data that we need. And then there's a beautiful function which can then take the descriptions from the Pydantic models and write the prompts that are required automatically for us to not only pull the data but also structure the data in the types that you have defined in your classes. For example, street is a string, and residing in address since years is an integer, things like that, right? Now, what we are going to do now is look at some real world documents, right? So documents are seldom clean and native text PDF. We don't get them in the real world. It's a different war zone altogether. So in this case, let's look at a couple of documents. So for example, let's look at the scanned loan application. First of all, this is a scanned document, and it's handwritten as well, right? So we have the name, citizenship, date of birth, and things like that. And in the second page, we also have a scan of this person's driver's license. To make matters worse, the orientation is completely off, whereas it should be landscape, is actually a portrait scan, right? Luckily, what we can do is that we can quickly check whether we are getting the information that we need using the LLM Whisperer playground. But before that, let's keep this around, just in case we want to have it as a reference here. Let's move it to the side here. Let's go to the LLM Whisperer playground just to see if we can upload this document and then quickly see how it works, right? So let's go to pick up and this document and send it to the playground. I'll have to verify whether I'm a human because there's no login or sign up required to use the LLM Whisperer playground. However, one point to note is that LLM Whisperer playground only extracts the first 2 pages, but that's 2 pages of the document, but that's plenty enough for us. It takes a few seconds to extract the text because it's doing OCR, and there we have it. So we have the type of credit, married, all the different checkboxes. We just hand checked, but then we did get those rendered really, really beautifully. That is super powerful because of the way LLM Whisperer works. And as you can see, it has no trouble pulling out handwritten text. It's done a really, really good job with numbers and with letters of the alphabet. Absolutely no problem there, right? And take a look at this is the page separator in LLM Whisperer, and it says that, hey, this page is done and the next page starts, and then this is the end of the document here, the last page separator. And it has no trouble actually pulling out all the information from the driver's license here. Although there's some minor mistakes, like California is a little off, but then you have the more difficult information is perfectly pulled out, right? Now this is great, so we can take this information and then pass this on to a large language model. So the LLM Whisperer playground is there for you to just very quickly check whether the kind of documents you have actually work with LLM Whisperer. You like I said, you don't have to log in or sign up for LLM Whisperer, nothing of that sort. And also very important to note is that LLM Whisperer is completely free for extractions up to 100 pages a day, and you can use it for OCR, text extraction, all sorts of things really, right? So this is good. We have what we need. So this is our reference. Let's first pull out information from this particular page, which consists of a bunch of handwritten text, right? This is very similar to the project we did last time, and this is the kind of code we need to get this going, right? So what we are doing here essentially is that we are defining a set of classes that hold personal information and contact information, the address data, and the details of employment and things like that, right? So I'm going to copy over a bunch of code. I already have the import statements ready, but as I'm copying the code over, I'm going to explain to you what exactly we are doing, right? So let's first copy over the Pydantic classes that define the model itself, right? So this is the main class. You have a form 1003, which is actually the name of the form. Inside of this, we have personal details, extra details, current address, and employment details. Now, here are the corresponding classes, which are Pydantic, basically subclasses of the base model. And then essentially here we have in the personal details things like a name, SSN, date of birth, citizenship. Then we have extra details, which has type of credits, marital status, cell phone number. In the current address, we have a bunch of things apart from the address itself. We have residing in the address since, and residing since years and months, and whether it's own house. There's a Boolean field, whether it's a rented house, and the actual rent, and if the mailing address is different, which is actually checkbox extraction, right? And we have employment details, and this is all, here too we have checkboxes involved, right? So this is good. So this is fairly simple code which just defines the model of the data that we need, right? We have we'll copy over this error exit function, which is just a utility function in case there's an error we just want to get out, right? Let's add a space here to make the linter happy, and we have this function, which is the function where we write the preamble. This is just a prompt that's sent to the large language model, and we have something called the postamble. In between the preamble and the postamble, we'll have the instructions created from the Pydantic object. So you see these descriptions here for each field, and of course we also have the type of each field, whether it's a Boolean or a string or a number, things like that. Now, based on these details and the type of the actual field, we just simply use this function called get format instructions, right? And then basically we are able to Pydantic basically in coordination with LangChain generates the code required to get the job done. I mean, write the prompts so that we get the right structure data from the large language model, right? So if you take a look at this function again, we have the preamble and postamble, right? We create a system template, system message prompt template, right, from the preamble. Then if you take a look at the human template, we have the format instructions, which will be our the instructions generated by Pydantic. Then we have the extracted text from LLM Whisperer, which is actually the extracted raw text of the form. And then we have the postamble, which is then included as well, right? Then we create the human message prompt template from this template. And finally, we create an instance of the Pydantic output parser, right? And then we pass the main object that we have written here, which includes the other classes as well, right? And then we say format prompt, and then we say from the parser, which is basically the Pydantic output parser, we say get format instructions, which then looks at the form class and then looks at all the other things that are included there, and using the description and also using the type hinting, it's able to generate the prompts to basically pull the information, but also format the information in the right manner, structure the information in the right manner, right? And of course, we're using OpenAI to basically, the default is GPT 3.5 Turbo, to basically send all these instructions and then structure the data, right? Now, let's come back to the code here. So we have extract text from PDF, which is super important. This is where we'll be calling LLM Whisperer. So if you take a look at this function, it's fairly simple. We have we already imported the LLM Whisperer client, which is a super useful library to have, and we simply call the whisper method. We pass the path of the file, and then we pass the pages to extract the list. We'll in this case need all the pages. We just pass a none. It'll basically pull out data from all the pages, and then we take the extracted text and then basically return it, right? So we look at the other functions, which is basically just a simple function to process. We just have a simple function to both extract the text first and then print the extracted text, and then pass the response, that extracted text, to the process 1003 information function, which should then do all the prompt engineering and then get the response from the large language model, right? Super simple. So nothing fancy going on here. It's pretty standard code and not very long. It's under 100 pages, 100 lines, I'm sorry. So here we have assets docs. So let's go ahead and create it and copy the file over. So we'll say new directory, we'll name this assets, and inside of assets we need docs, I believe, and inside of this we're gonna copy over our file, which is let me pull that out. We have this here, copy this and go over to PyCharm projects, handwritten PDF extraction, assets, docs, copy this over. Perfect. So we have this here. Just gonna edit the name of the file to sample scanned loan application.pdf. Perfect. And I'm gonna just knock off the page list so that it's just null, so that now it should be able to extract all the different pages, right? We can actually run this and see whether this works. Let's try that and see what happens. There you go. We did get back the extracted raw text, which is format preserved, has all the right information in there, although it was actually handwritten. Let's go back to the reference. Here it is. And there you go. Here's the JSON data from the large language model. Looks like it has done a good job of figuring out the structured information here. It's perfect. So, if you are the business owner is what is checked, so it got that true. And we also checked that it's a 25% or more ownership, which is also true. And this is a checkbox as well. Mailing address is different. It does not apply, so that's perfect. And looks like it, from a quick scan, it does look like it got all the information correct, including US citizen, which is a radio button here. That's great. Now all that is that needs to be done is we need to write a quick class which can pull out data from the driver's license. And if you look at the playground information, this is the raw information that got pulled out from the driver's license. So we could ask it information like the last name, first name, address, date of birth, the state of the license, the gender of the individual, maybe something like that. We could try something like that. And let's say we create a class, a Pydantic class to do just that. Let's do that. Let's say that's right. So we'll have the state, which is a string. Although the state is a little pulled out slightly wrongly, the large language model should be able to correct it for us. This is the number of the driver's license. We need the issue date. What else do we need? We need is the issue date really there? There's the expiry date, but I don't see the issue date here. Let's see. I think this is probably the issue date. We can figure out if it pulls it out. The expiration date, state of issue. Okay, let's delete this then and go with this. Just goes well with whatever we need. All right, so we can also pull out maybe date of birth and last name and first name. And the first name, we need that, and then don't need the middle name. We probably need date of birth, right? There you go. Perfect. Now let's take this. Let's insert a space here so that the linter is happy. Delete a space here. Come down. Add license details. Driver's license. That's right. Perfect. This is a good suggestion which we will accept. But then let's go ahead and correct the spelling for this. All right, so we have, it should actually just work now, if you ask me. The JSON should now contain the license details as well. Let's run this and see, try our luck here. We have the extracted text. Let's wait for the large language model. Perfect. So we have the issue state, we have the issue date, then we have the date of birth. I think the expiration date and issue date is a little off. I think it's got the expiry date for both the issue date and the expiration date. I think nothing that we can't fix with a little bit of prompt engineering. I think the ISS is the field that has the issue date. That's something we can easily fix. And expiry date is something we can just accept. And it got the name perfectly. We can also ask for the full name of the state, right? So let's go here. We can ask for the full name, state of the issue of the driver's license in its full form, right? And the issue date of the driver's license. Okay, we're adding a little bit more information, which could do the trick. Some formatting that's suggested. Let's say fill the paragraph, no problem. Let's go with that. Let's try running this again. It's still struggling with the issue date, which it is confusing for the expiry date. The issue date is 2009. Issue date, the field name of the issue date is sometimes abbreviated as ISS. Do not pick up the date for this. Pick up the expiry date for this field name, which is earlier than, which is actually later, and the issue date. Let's try this prompt, and we'll fix this later. Let's run this now. Perfect. So after adding a lengthier, more descriptive prompt, now we have the issue date pulled out properly and along with the expiry date as well. That's great. We even got to see what kind of problems you might see in real world with prompts, and some techniques to basically improve the prompt to get you the right information. Of course, this can get a little bit more complex when when things get a little murkier with different formats and things like that. It's not easy to it's not very easy to solve these problems sometimes, but prompt engineering does go a really long way better than what you can do with traditional programming, right? Awesome. So that was another video where we saw more real world, more challenging use cases. I hope you enjoy this video. Thank you.